So yeah, this is my topic 2 discussion video for the chapter 12 on Project Rationale. This is the thing. So for number 1, Megan decides to tackle the budget first. After reviewing her budget, she decides that she really needs to get a part-time job to earn some extra money. She is remodeling the living room and would like to buy some new furniture. Letting X represent her new monthly combined salary, she estimates that 1/4 of her new salary be used for bills, and approximately 1/5 for her car payment. She would like to have $1,100 left over each month, of which $100 will be saved for the new furniture. So what must her new salary be? So for letter A, let the variable X represent Megan's new monthly salary. We need to write an expression to represent the amount of her new salary used for bills. And the equation I came up with was 1/4 X equals bills, because 1/4, it clearly states above, it says 1/4 of a new salary will be used for bills, so it's 1/4 times X equals bills. For B, write an expression to represent the amount of Megan's new monthly salary used for car payments. This is the same thing, except instead of having 1/4 of her new salary used for bills, we're using 1/5 for her car payment, so it's 1/5 times X equals car payment. Okay, write an equation that sums the expenditures and leftover balance and set the sum equal to the new monthly salary of X. So the sum of expenditures is it's the new salary used for bills and the monthly salary used for a car payment. So that's 1/4 X plus 1/5X. That's all in closed parentheses right there, as you can see right here. And then you add it plus the 1,100. This is taken from the 1,100 left over, which is the leftover balance, and we set all this equal to X. For D, it says to find the least common denominator of the rational expressions from part C and multiply by each term in the equation to remove the fractions. So the least common denominator of 1/4 X and 1/5 X is 20, because 4 times 5 equals 20. So in order to do this now, we would multiply the whole equation from C by 20, which is seen here. And then from there, we would get 5X, which is 1/4 X times 20 equals 5X. 1/5 X over here times 20 equals 4X. So 5X plus 4X plus 22,000, which is 1,100 times 20, and it's 20X. That's our new equation. So solve the equation from part D to determine what Megan's new monthly salary needs to be. Okay, from here, we take this equation. So it's 5X plus 4X, that gives us 9X right here, plus the 22,000, and equals 20X. To do this, we would solve for X, we would move the 9X over, so subtract 9X from both sides. That becomes 20X minus 9X equals 22,000. 20X minus 9X is 11X. 11X equals 22,000. Divide 11 from both sides, and we get X equals 2,000. Approximately how much of Megan's new salary will be used to pay for her car payments? Well, if we know X is 2,000, and the equation from above was here, 1/5 times X equals car payments, then we just plug in X, which is 2,000. So 2,000 times 1/5 equals 400. So about $400 of her new salary be used to pay for her car payments. Okay, now number 2. With the budget done, Megan prepares to paint the spare bedroom. She just finished painting her bedroom last week, and it took her about 4 hours. Her roommate Ashley painted her bedroom a couple weeks ago, and it took her 6 hours. All the bedrooms are similar in size. Megan realizes that if she gets Ashley to help her with the painting, it would take less time, and they can get to the lake sooner. How long will it take Megan and Ashley working together to paint the spare bedroom? Use the table below to help you set up the problem. So, this is the table. Person here, Megan and Ashley. The time, 4 and 6. Together is X, because that's what we need to solve for. And the part of work done in 1 hour. So I filled in the missing information. So this is the original given information is 1/X for total work done in 1 hour. And for Ashley, it'd be 1/6. And same with Megan, it'd be 1/4. Now, use the entries in the last column of the table to set up an equation to represent the sum of the amount of work done by Megan and Ashley in an hour, And that's pretty easy. It's 1 over 4 plus 1 over 6 equals 1 over x. And to see, solve the equation to determine how long it will take the two girls to paint the spare bedroom when working together. Express the result as a decimal to the nearest tenth. Convert this measurement to hours and minutes. Okay, so from here, 1 over 4 plus 1 over 6 equals 1 over x. That's the equation we're given. To make sure that we can add those 1 over 4 and 1 over 6 together, we need to find the least common denominator, which would be 12, because 3 times 4 is 12, and 6 times 2 is 12. So for 1 over 4, it would be 3 over 12, and 1 over 6 would become 2 over 12. And if we add those together, it becomes 5 over 12 equals 1 over x. Now to solve for x, we multiply both sides by 12 over 5. And so x equals 12 over 5, which equals about 2.4 hours. And 2.4 hours equals 2 hours and, what is it, 0.4. 0.4 of an hour. So that's 60 divided by 5. It's 12 times 2. It's 0.4, so it's 24. So it's about 2 hours and 24 minutes. Alright, so with number 3, with the spare bedroom painted, the girls call Lucas to let him know they are ready to head to the lake. While he is preparing the boat for the lake, Lucas is trying to decide which route they should travel to get there. If he travels the highway, he can travel 20 miles per hour faster than the scenic route. However, the highway is 30 miles longer than the scenic route, which is 60 miles long. Lucas thinks that it should take him the same amount of time to get there using either routes. Using the following table to help you organize the information for this problem. So, for both, we have distance, which is one for highway and one for scenic route. The distance for the highway is 90, while the scenic route is 60. And so here, the rate for the highway was x plus 20. So it's 20 miles faster. And then for the rate for the other one, it's just x. And for time in hours, it'd be 90 over x plus 20. And the other one's 60 over x. Okay, that was A. For B now. Since Lucas expects the time to be same for each route, create an equation from the time column and solve for x. Well, you would just take 90 over x plus 20. Make sure x plus 20 is in parentheses, or you might get a different answer. And set that equal to 60 over x. From here, we just cross multiply, which means 90 times x equals 60 times x plus 20. Now there's no more denominators, so we can move on from here. We can expand on the 60x plus 20, which gives us 60x plus 1,200. Now we subtract the 60x from both sides. So 90x minus 60x gives us 30x here, and that equals 1,200. Divide both sides by 30, and x equals 40. How fast must Lucas travel on the highway to get to the lake in the same amount of time as traveling the scenic route? So remember, the highway is x plus 20. That's the rate. So if it's x plus 20, and we know x is 40, we plug that in. It's 40 plus 20 equals 60. So Lucas must travel 60 miles per hour. Now, this is my own-ended question. If the girls want to slow down more on the scenic route to a rate of x minus 10 miles per hour, how long will it take the girls to arrive? So remember, the distance for the scenic route is 60 miles. The new rate is 40 minus 10 because it's x minus 10, and we know x is 40. So the new rate is 30 miles per hour. And now to get to the new time, it'd be 60 divided by 30, and that gives us 2 hours. So it's a little bit longer. Thank you.